Let's talk about something straight out of science fiction, building a human city on Mars. It's a dream, right? But the first step toward making it real, it doesn't start with astronauts. It starts with an incredibly tough test for machines.
I mean, seriously, how do you even begin to build a city 140 million miles away? It's one of the biggest questions we can ask. And the answer? Well, it starts somewhere you probably wouldn't expect. That's right, the very first pioneers, the ones who are going to lay the foundation for humanity on Mars, they won't be human at all. They're going to be fully autonomous robots. Now, I know what you might be thinking. Sending robots to do such a human thing seems a little backward. But really, it's not much of a choice. It's an absolute necessity. And it all comes down to the brutal realities of space. First off, just try to wrap your head around the distance. On average, we're talking about 140 million miles. That is a long, long way from home. Getting people, supplies, anything there is a gigantic undertaking.
And then, when you finally get there, it is unbelievably cold. The average temperature is around minus 80 degrees Fahrenheit. That is an incredibly dangerous and hostile place for any human to be. So you put that all together, the enormous distance, the extreme danger, and the bottom line is sending people first just doesn't make sense. The robots have to be the advanced team. They have to go build us a home before we ever show up. But here is the real kicker. This is the central problem. If a robot on Mars breaks apart or needs a new tool, you can't just ship one from Earth. That delivery would take months. That's just not going to work. These robots have to be 100% self-sufficient. And that reality gives rise to a whole new kind of challenge.
And that challenge has a name, the Mírdain test. You can think of it as the ultimate final exam for any robotic system. It's designed to prove once and for all that a machine can survive and build all on its own. Let's break this down because every part of this is critical. Create something from scratch means no IKEA kits shipped from Earth. Using only local resources means it has to live off the land. And zero human help? Well, that speaks for itself. Total autonomy. Okay, so the test really boils down to three main pillars. Three things a system has to master to pass. It has to design, it has to plan, and it has to manage its own materials. So first up, design. The system can't just pull a standard blueprint out of a database. No, it has to look at the Martian environment and design what it needs specifically for those conditions. That takes genuine creativity, a kind of problem solving we usually think of as uniquely human. Okay, next up is planning. Once you have a design, how do you actually make it with the tools you've got? And here's where it gets really wild. What if you don't have the right tool? Well, the system might have to design and build a new tool first. It's a massive, complex logistical puzzle. And finally, and this might be the most incredible part of all, it has to manage materials. Remember, there's no hardware store on Mars. The robots would have to literally mine the soil for things like iron, and then figure out how to process that raw material into something useful, like a metal sheet. This analogy is just perfect. It's not just about cooking the meal. The system has to be the farmer, the harvester, and the chef. It has to control the entire supply chain, from dirt to dinner plate, all by itself. So, this is all fascinating, far-out space stuff, right? Well, yes. But what's really amazing is that the Mírdain test isn't just about going to other planets. The implications of passing it could completely change life right here on Earth. We talk a lot these days about AGI, artificial general intelligence. That's the quest to create an AI that masters the digital world of information and thought. Well, you can think of the Mírdain test as the other half of the equation. It's the benchmark for mastering the physical world. And that's a huge deal, because it means this isn't just some abstract sci-fi idea. Achieving this level of robotic intelligence would have a direct, profound impact on all of our lives. I mean, just imagine what robots like this could do here. You could deploy them to a city devastated by an earthquake, and they could just start rebuilding. They could work in incredibly dangerous jobs like deep-sea mining or nuclear cleanup so humans don't have to. The possibilities are staggering. So ultimately, the Mírdain test is way more than just a pass-fail exam for a robot. It's a vision. It's a guiding light for where we're going with automation and robotics. So where are we now on this journey? Well, today, our robots are amazing at specific repetitive tasks, as long as a human is guiding them.
But things are moving so fast. We're seeing huge leaps in AI and in technologies like 3D metal printing. All of these things are pushing us closer and closer to that ultimate goal.
That's why people call it a North Star. It's this single, clear, ambitious goal that helps focus all of our smaller efforts and guides them in the right direction. Every step we take towards it is a meaningful leap forward for our technology.
You know, it's pretty incredible to think about. The very same challenges we need to solve to build a new world out there in the stars could end up providing the solutions to some of the biggest problems we face right here on our own planet.
Which leaves us with one last pretty fun question to ponder. Once we finally have machines that can pass this test, machines that can build anything, anywhere, from scratch, what is the very first thing we should ask them to build?